Hello everyone and welcome back to the channel. In this video we're going to take a look at this power station. It is the UPP -1200 model, so it is 1.2 kilowatts. These come in many different brands as OUPES, I don't know how it's called, or all power, I think it's called. And what these have, they have a DC section with fast charging USB, USB-C power delivery, car plug, and of course our pure sine wave inverters. This one got the E005 error, and I got this from a customer for repair, and actually it had defeated me. I mean, I've checked everything inside and didn't manage to find the fault. However, the reason I wanted to make this video is because, as you can see, this thing has this orange rubber thing around it, and it is literally impossible to disassemble. As you can see, I had to drill many test holes. I don't know, you can see here, in order just to open it. And not only that, there were the feet that, let me find it, have these bars inside with a screw that I forgot, of course, to remove, and I was pulling like crazy. As you can see, more screw holes here, and they have these plugs, so in a couple of cases I drilled this inside and it was impossible to take them out. I used the wood screw for that. Interestingly, poking around with the BMS, something changed. We will see it in the video. Now just take a look. The manual is just a generic, I mean, doesn't really say much about its use. You plug in the charger here and it charges, and that's pretty much it. You can of course use solar panels through this plug in order to charge the power station from solar. Now our error, as you can see, not much information: BMS fault, charge over voltage, discharge under voltage, high temperature, low temperature, and short circuit protection. I mean, nothing was sorted inside. And first of all, I will take a couple of pictures for the screw location, and we will see the screw places that someone that has to do the same job needs to do. Now this is a sneak peek from inside and how it looks, and of course here is the inverter with the, here is the battery BMS, and we can almost see the LiFePO 4 cells inside there. This is a 32 volt battery, meaning they have 10 cells in series. Everything connects through this connector to the main PCB, and I noticed that here there is a on-off marker. Let me, so here we are. One of the things I did is I sorted those two pins that they didn't have any voltage on them. We will take a look when I connect everything back. I wanted to take sneak peek of the, so this is the power inverter. These plugs are what it is used for the sockets, the power sockets outside. I mean, it looks kind of tidy. Of course, Samsung caps, you wouldn't expect anything better really. And of course the front panel with all the DC power stuff. Let me start assembling this and we will take another look when everything is connected. So here is the power station assembled. Let's take a look of its operation. So we get the battery state, which is 81%, and if we press here we switch on the DC part. We can see how many watts we're pulling, and if we connect the charger we can also see how many watts are going to the battery. Here is the AC part. As you can hear, the fans kicked in for a while but turned off finally. And should we connect something? Just to see how much it pulls. Switch off the AC as we don't want that. So this is a light and it currently is charging at 3 watts. If I turn on, you can see 8, 9, 10, 11. And we get a reading of our remaining battery time with the current consumption. Switch off the light. It still takes about 10 watts. So that would be all for today. If you happen to come across to such a power station and find a way to reset it, if that small PCB did the trick, please leave it in the comments below. Hit the like button if you found this video interesting, and please consider subscribing for more. Thank you for watching and see you on the next one. Bye.